Hi, welcome back again to another episode of Dynamic Machine Podcast. The last episode I talked about which machinery is needed to produce vaccine. We talked about bioreactors and fermenters. In this session, I would like to talk about mechanical separators and the way that is needed to filter the vaccine. Please stay with me and follow me.
So, as we talked about, mechanical separation is a form of filtration that is needed because in the previous steps, as I talked, in bioreactors and fermenters, we use a lot of ingredient to cultivate the virus or the dead virus, in fact, or a part of the virus. You know, it depends on the primary steps that was taken, what type of virus was put inside the bioreactors. But at the next step, that all these viruses are cultivated and there is a huge number of them, there are some materials that should be separated from the vaccine, in fact. So what we need, in fact, is a way or a device that can separate or filter the other molecules from the main molecules that are needed in the vaccine. One way of doing such a thing is a mechanical separator, but let's see how it works. In fact, a mechanical separator is just like a centrifuge. In fact, in brewery industry, this type of mechanical separation is also used. As you see in this page, as I said, GEA, which is a German company, is producing actively machinery needed for pharma and food industry and liquid industry. They actually have very good and high quality mechanical separators. And they actually look like that, as you see in the picture. It's like a big bowl, and this big bowl is rotating and kind of like based on the changes of the density and the characteristics between the fluid and solid, available solid particles in the suspension liquid. It can separate the liquid and the solids. If I want to clearly show you how this bowl or how this centrifuge is working, I can show you a better picture, maybe for better explanation. So this is also another company that produce this type of mechanical separators. Here there is a very nice picture that I can explain a little bit how this works. In fact, from here, the ingredients or the liquid comes from the bioreactors, enters in this channel, and it's kind of like pumped through this channel. And at this level, this mechanism with separated disc starts to rotate. And the rotational acceleration cause the heavier particles to go through this centrifugal acceleration to the sides, and the liquid or more, let's say more liquid ingredients or content to stay in the middle. And somehow this separation makes the higher density materials or liquids molecules comes to the sides, and less density and liquid to stay at the center of this machine. So there is, as you said, as you remember, in bioreactors uh, there were some kind of control. That one of them was the oxidation of the liquid. There is a lot of reason that oxygen should not get inside the liquid or suspension because it's cause problem later for the patient. So it's very important the process of the oxidation in the bioreactors, and as well in the centrifugal level and separation or filtration, oxygen should not get included in any way into this content. But it's not an easy job because always we cannot really seal everything, and this is a rotating object, solid, and kind of sealing that there is no way of oxygen to get through the passages and to get into the content is not an easy job. So there is a question that how we can achieve that. So how we can really achieve that? The process is called hydrohermetics. So hydrohermetic sealing is one way of achieving the oxidization of the content of the liquid. In fact, how it works. In a very simple explanation, it's in fact there is a kind of solenoid valve, and between the atmosphere and the content available in the machine, there should be a kind of interface that kind of put a barrier between the content of the liquid and the atmosphere. So there is no way of interacting of oxygen with the liquid. The way that they do that, so-called hydrohermetic sealing, is through adding water or degassed water. In fact, water through adjusted valve will be provide a shelter uh, for the liquid to pass through without contacting the air or the oxygen. I'm not sure, but probably water uh, is harmless and it won't cause any problem at degassed and pure water. And but maybe there are some other way as well to achieve this protection. Maybe we can use also some gases. I don't know, like argon or something like that. I'm not sure. Probably not for vaccination or pharma methods, but so far water can be one option. So we realized that how hydrohermetic sealing works, and now it's clear that using a built-in disk in this structure, the liquid or the purified or filtered liquid will move to the next step. So it's really dependent on the process and the way that the vaccine is produced, but there can be a next level of filtration. Chromatography is a one way of extra steps for insurance that the vaccine is purified, and there are different ways and methods for chromatography. As you see in this article, chromatography is a separation science, and it's a very vast science that there are different ways and different methods to separate molecules from each other. But as I have researched, the one methods that is used in the vaccine production is so-called affinity chromatography. Affinity chromatography works based on ionization of the ligands. In fact, in a very simple explanation, the targeted molecules will be binded with a specific type of ligands. And these ligands, let's consider that there's a matrix, and these molecules or target molecules, which we call them as the dead viruses or whatever the ingredient of the vaccine it will be binded with ligands, and these ligands can help the contents to be separated from the rest of the material available in the content. And these ligands or ionic molecules can be also later separated from the targeted molecules that we were looking for. And this can be separated later by change of pH level or hydrolyzation, or even by change of ion or ionic methods. And then we have a very purified. The only problem with chromatography is the time consuming. It is a time consuming process. So there are some companies that are producing continuous chromatography machines. For example, one that I have realized is this machine from Novasep that works for pilot level or pilot base, higher, greater amount of production. So this will I will talk about the machinery and which companies are actually producing chromatography machines later in my website, in my blog. In fact, I will talk about the different manufacturers and which companies and which countries are actually producing filtration for the vaccines. But so in this episode, we talked about the available separators, mechanical separators, centrifugal separators, and also chromatographical machines that can be used for filtration and is of one essence for the production of vaccine. I hope that you enjoyed this material and information. I keep studying about the vaccine machinery used in the vaccine production, and hopefully in the next episode we will continue the rest of the journey together. Thank you very much to be with me and to follow my podcast.